Here's an image I got from the internet that shows using cross multiplication or the butterfly method to solve a proportion. Here's another image from the internet, same idea, butterfly method or cross multiplying to solve a problem using percents. Here's the butterfly method to figure out which fraction is larger. Here's a bunch of cute butterflies drawn to help people figure out how to add fractions. And of course, if we've got addition, we also need an example for subtraction. Hey, look at that butterfly. Here's the butterfly method used, I think, to simplify fractions. I'm not sure why they're using that instead of just dividing across, but hey, it's the butterfly method. Here's an image that says it's about multiplying fractions, but thank goodness it's really just showing how to add two fractions using the butterfly method. And here's an image that says it's about using the butterfly method for adding and subtracting fractions, but it's not really, because all the examples just show using the butterfly method to check to see if fractions are equivalent. And here's why I don't teach the butterfly method. So let me be honest, if I've got an equation like this, of course I'm going to use the butterfly method. I'm going to cross multiply, I've got complicated expressions, I'll go ahead and I will solve for x. But I want to point out that this is not a 6th grade problem. This is not something that I would expect to see at the beginning of middle school. This is something that I expect to see for algebra. I don't teach the butterfly method in 6th grade, and I'm not alone in this. What you are looking at is the State of Louisiana guidelines on how to teach different standards in 6th grade. This standard is about ratio and rate reasoning, where you might see the beginning of proportions. And look, the cross product algorithm is not expected at this level. So with that background, let me talk about why I don't teach the butterfly method. Remember all these images? There are a lot of students and parents who think that if you have a fraction problem, you automatically need to use the butterfly method. But that's not true. It doesn't work for fraction multiplication or fraction division. As math teachers, we want to teach students not only how to use tools, but how to carefully select them. We don't want to encourage the idea that one method solves all your problems. Notice what happens when we use the butterfly method to compare two fractions. We turn a question about two fractions into an answer about two natural numbers. We know which fraction is larger, but we don't know from the fractions themselves why one fraction is larger. But if we use equivalent fractions instead, we answer the question and learn why 5/7 is the larger fraction. We use equivalent fractions, so we know more about the fractions we started with. And there are lots of problems where the butterfly method should be replaced by good, solid understanding of fractions. I know 1/2 is less than 7/8 because 1/2 of 8 is 4 and 4/8 is less than 7/8. I know 1/9 is less than 14/15 because 1/9 is close to 0 and 14/15 is close to 1. I know 5/4 is greater than 7/9 because 5/4 is greater than 1 and 7/9 is less than 1. No butterfly method needed. When it comes to addition or subtraction, the butterfly method tells you the right answer, although it may have to be simplified. But again, it doesn't tell you why. If you use equivalent fractions instead, you use some of your previous fraction knowledge, hopefully you don't have to simplify, and you have a better understanding of where all the numbers come from. Again, good solid fraction understanding can help a lot. If we use the butterfly method to add these three fractions, we have to use it twice and get some relatively large numerators and denominators. If we use fraction equivalence instead, we have nice small numbers and a much easier path. So, what am I advocating? First, try not to use the butterfly method whenever you can. It's a standard tool for solving proportions, but try to avoid it for fraction addition and subtraction. Second, build up number sense with fractions. Help students understand fractions conceptually by using visuals like tape diagrams and pie charts, and especially number lines. And third, emphasize equivalent fractions whenever you can. Focusing on equivalent fractions not only helps students understand fractions better, but it will help for future mathematics like rates and ratios and lots of algebra. In the future, when you see the butterfly method, be cautious. There may be a better method, and never mind. You're good. Carry on.